Okay, my friends, here we have a Sub-Zero 424 wine cooler. We just brought this into the shop and it has a problem because it runs and it doesn't cool. And so we're going to run it through diagnostics. We've already run it through diagnostics in the customer's home. And the compressor runs, but there's no flow of refrigerant, so we're thinking that it's possibly a switching valve or a restriction, because when we shut the compressor off, it remains deep in a vacuum and it doesn't balance out. So the first thing we'll do is drain the freon out. We'll get our recovery system and drain the freon out so we can check the sealed system. And if there's no freon in there, then we'll know it's a leak. But normally when there's a leak, when you shut the compressor off, the pressure will rise. And at this point, it just stayed where it was. So stand by. Okay, so let's remove the rear cover first, and then get this out of the way. Now, someone already put a line tap valve on here. The customer said that someone had put gas in it a while back. So we'll tap into this and then we'll see what our pressure is. Okay, so now we have our compound gauge hooked up here. Low pressure side, we're going to open up this line tap valve. Very little pressure in there. That's leading me to believe that maybe this has a leak and it's not a switching valve. So let's plug it in. Okay, plug that in there. It's pulling down in the vacuum now. That's an indication that it's low on freon, but not always. In this machine, you have one compressor and you have two evaporator coils, two separate sections. So they have a switching valve in there and it goes back and forth. It cools down one compartment and then it switches to another. So it seems to be balancing out right now about 12 inches in a vacuum. So let's shoot some freon in here and see what happens. Okay, we're at 134A here. I'm going to open this up. I'm going to bleed out a little bit of the air. Now we're down to about 15 inches in the vacuum. So I'll put some freon in here. Now, before I brought this machine into the shop, I was at the customer's house and I did put some freon in there, but the temperature didn't move. So that's why I assumed it was the switching valve, because it was locked in a vacuum. But since it's been sitting and turned off over 24 hours, not very much pressure in there. Normally Freon 134A at room temperature is going to give you probably somewhere around, 40 pounds back pressure. These machines only take about 3.5 ounces of freon, so you have to be careful not to overcharge them. And we don't normally charge them this way. We drain all the gas out and then pull a vacuum on it, and then we weigh the gas in with the charging column. So either this thing is leaking right out because it's not holding any pressure, or the switching valve or has a restriction, or the switching valve is defective. It's almost down to 20 inches of vacuum. So let's see what happens when we pull out the plug. The pressure should come up. So this is what leading me to believe that there's a restriction in here, or there's a blockage somewhere. It could be the switching valve. So let's get our leak detector and see if that helps. Okay, I'm using this AccuProbe from Yellow Jacket. Your evaporator coils are in here, and the heat exchangers run through here. Your switching valve is in there. Let's go inside. Up. It doesn't mean there's a leak, because when they make these machines, they blow the insulation in with freon, or at least they used to. I don't know. And then sometimes you could be picking up traces of freon, and it's not having a leak. But I think the next step is to pull the machine apart, expose the evaporator coils, and see if we can see any oil in the drain trough. That would be a sure indication that there's a leak. Stand by. Okay, as you can see, we've got the covers off, and let's see if we can pick up you can see a little corrosion there, some oxidation on that line, but let's see up here. I guess it could be up here, so we're going to have to pinpoint that leak. We use our ultrasonic leak detector to see if we can pinpoint it, or we could even use bubbles. Bubbles might help. Okay. Okay, we're using our ultrasonic leak detector here, and nothing. There it is, right there. I'm picking up, you can see the scale on the meter. See it jumping up and down? That leak's right there. So now that we know where the leak is, we can just verify one more time with some bubbles, and just so we know which if it's in an area, if it's copper, we can just weld it. But if it's leaking from the blast joint where the copper meets the aluminum, we'll have to change the evaporator. Okay, some bubbles. There it is. See those bubbles? The leak is there. This is copper. It goes into aluminum. This is the blast joint down here. Nothing leaking there. It's up here in the copper. Right there. So the next thing we'll do is we'll pull this evaporator away from the wall. I don't know if this looks like a factory job, but I don't know if you can notice down here the suction line is twisted and kinked a little bit. I guess they did that when they built it. But we got a leak right there. So what we can do is we'll sand this down and repair that leak. Okay, stand by. Okay, so now we're setting up our recovery system here, and we're going to drain the freon out of the system, put it into this charging column so we can reuse it. I doubt if there's much in there anyway. Okay, we'll close off our tank. I generally wait until it's about 10 inches in a vacuum, and then I'll shut off the machine and open up the lines. Like I said, I don't think there was that much freon in here to begin with, so we were able to find the leak. I have a general idea. The leak is right here where the cap tube, let me get my light, where the cap tube comes in to the evaporator coil. Here's your blast joint right down here. So this is all copper and it's corroded here. And the bubbles are coming from right about here where my finger is. So I'm going to sand this all down. I'm going to just solder in this area, and then we'll recheck it for leaks and see. That would be a really easy fix. Okay, so we're down about 15 inches of mercury here in vacuum, still coming out. I don't see anything in here. It's bone dry. Let me see. Don't see anything. So alright, so we shut it off. It's still in the vacuum. We're good. We're good, it's empty. Let's take this out and see if we have anything in there. I don't see anything. The system's completely dry. And because it was leaking on the high side, the high pressure side of the line, it leaks out much faster. So now that we have the freon out and the system is empty, next step would be to sand that copper down there and try to get in there with a really small micro tip, like maybe a number 3 tip, and weld that up. Okay, so I've sanded this down and wire brushed the area where I'm going to solder here. The leak is somewhere in here, and I kind of blocked off with this aluminum plate so that the heat will not melt any of the wires. You have to be really careful. I'm going to use a really small tip, a number 3 tip, to a concentrated flame so that the heat doesn't spread out. And so we'll get that tip and we'll get soldering. Okay, so here is our number 3 tip. And this is the flux we're using. It's Harris Staysil white brazing flux. So First I'm going to do a little bit of heat. I'm going to heat it up a little bit so the flux will kind of melt in there. You notice how small that flame is? So I'm heating it up to burn off any oxidation, any chemicals on there, oil and stuff. Then I'm going to put some flux on there. I may have to change glasses. These video glasses that I'm wearing, I mean, most people that watch my videos know I use these video glasses because I have to work with both hands. But I can't see as well as I could with other, close-up glasses. So let's try. We got our 56% stay-still solder. You can also use a brazing rod, but I like this. It flows a little better. All right, now we're going to have to pressurize it and check for leaks again. Okay, so we've pressurized it. It's about 60 pounds pressure in there. That's about right because it's about 50 degrees in my shop here. There's a lot of freon on the air, so and I'm not picking up anything here. So let's verify with the the ultrasonic. See, I'm picking up senses out here, but not inside. So I'm going to shut this off. These things are so damn sensitive, and we're going to use the ultrasonic leak detector, and if we don't hear any bubbles over there, well, that would be a good thing. Now stand by, let me get this ready. Okay. I still hear. I'm going to check it with soap bubbles. Okay, we resoldered it. Looking good. By George, I think we've got it. So we'll just double check it with some soap bubbles, and then we'll pull a vacuum on the system and recharge it and weigh the gas in. Okay, so we're going to clean this up, reassemble it, pull a vacuum, and then recharge it. Okay, we let this sit overnight, and the pressure is still there, so we can rule out that it was leaking. Now we will do the cleanup and put it back together, and then pull a nice deep vacuum on it and recharge it. Okay, it's all back together, cleaned up. So now next we remove this tap valve. We just took the tap valve off here. We're going to cut this and we're going to put a process port on there, which is, in my opinion, a little safer. So we'll do that and then we'll pull a vacuum on the system. Okay, so we cut that off and now we're going to clean this tubing here. Okay, now we're going to remove the Schrader valve out of here and then we're going to clean the inside with a wire brush and then we'll weld it on. So just take a tool and remove this little valve in there. It's called a Schrader valve. It's got a little seal on it, so if you heat it up without removing this you could melt the seal. So then we'll take, let's see, get a wire brush here. We'll clean this out. Score it up a little bit. Give the solder something to stick to. Okay. We'll take our flux. Put a little bit of flux on there. Okay, now we're going to get some aluminum and block this wire so we don't burn it. Okay. Let's put our number 5 tip back in here. Okay. Let's see what we did with it. It's around here somewhere. Okay. Number 5 tip. And I usually wait until the tubing or the brass fitting gets red hot or close to it. You can see it's starting to glow now. That's it. Okay, we'll let that cool down. We'll put the Schrader valve back in, and then we'll get our vacuum pump set up. Okay, so now we got our vacuum pump. I'm going to pull a nice deep vacuum on this thing. I don't know, I just bought these hoses online. It says Yellow Jacket on them, which is a really good brand, but for some reason or other these hoses are hard and stiff, and I've never encountered that before, so I'm just wondering if they're not made offshore somewhere. Okay, so that's on. We'll turn on the vacuum pump. Open up the valve, open up our gauge, all right, We're going to let that run as long as we may have to. Put a nice deep vacuum on it, and then we'll be ready to charge it up. Okay, we're back. We let it run for a couple of hours. I had to go run an errand. So we'll shut off the pump. It's down, it says 30 on the gauge. We all know, refrigeration techs know that you can't get a perfect vacuum, but it's down pretty damn close, 29 point something. So shut that off. This is closed. Shut off the pump. Disconnect the line. And that's it. So now, the next thing, we'll let it sit for a while and make sure it holds a vacuum, and then we'll recharge it. Okay, so we let this unit sit overnight. It's still down close to 30 inches in the vacuum, so we're pretty sure we got the leak all covered and fixed. So now we're going to wave the freon into our charging column and then charge it up. Okay, so this unit takes 3.3 ounces of R134A. Okay, so we're using the R12 scale. We have a little over 3 ounces in here, and that should be sufficient. Now we'll hook up our charging column and we'll invert it so we only charge the system with vapor. And then we'll get this baby up and running. Okay, so now we have our charging column hooked up. We're going to open it up. We're going to purge out a little bit of, in case there's any air in the line, just a little bit. That's it. And then and shoot some into the system. We're charging it with vapor, and then we're going to plug it in. Compressor's on. So we'll just let that go in, and we'll let it run. And we'll check the temperature. We'll let it run, I would say it's already at 57 because that's the temperature of my shop. So let's see, we'll put this down to 44. No, we don't want to go that cold. Let's just put it down to 45. And leave it at that. So we're going to go out and run on a job. When we come back, we'll check this out, and if it's okay, we'll button it up and bring it back to the customer. Okay, our charging column is starting to frost up because the pressure drop on the freon. I'm going to heat this up. I don't know if you can see the charging column has frost on it. So I'm going to heat this column up to raise the pressure inside to force the freon into the system. Okay, so we got all the freon in the system. We let it run. It's still running deep in the vacuum. It's not circulating freon, so we have additional problems here. Most likely it's going to be the switching valve, or it's possible that because it had a leak on the evaporator coil, it might have sucked in some moisture and clogged up the system, even though we pulled a really deep vacuum on it. So the next thing to do is we're going to remove the screws down here in the bottom that hold this base to the cabinet. We're going to lift this up. The switching valve will be in there, and that will be the next thing to check out. So stand by. Okay, to gain access to the switching valve, we're going to remove these 4 screws here. And then you'll see there's one switching valve for both coils. In the earlier versions of these wine coolers, they had 2 separate valves. All right, so once you get those screws out, then you have to lift this up, separate it, and put a block of wood in there. Okay, so here's the switching valve in here. We're going to disconnect it and pull it through so we can get to it. There's one filter with a dual outlet, and each one goes to an evaporator. And when these things go bad, they don't open, and they could cause a restriction. So we have only 45 pounds pressure in here, and it should be higher than that. So I think I'm going to recheck, make sure we'll recover the freon and make sure we pull out 3.3 ounces. If not, then that means we still have another leak. Okay, it looks like we pulled out 2.5 ounces. At least it's not empty. So I'm assuming that the other 1/2 ounce or more is in the hoses and in the machine itself. So that's not too bad. So now I'm leaning more towards the switching valve. So I will order a new switching valve, and then next step is I'll show you how to replace it. Okay, so here's the switching valve. I disconnected the upper evaporator. Here's the cap tube right there. I also cut off the end of the filter and discovered when I pressurize this with nitrogen, some liquid came out of there. That means there's moisture in there, and it was plugged up. See that? There's something in there. Most likely it's sucked in some water from that leaky evaporator coil. We got, my nitrogen tank is nearly empty, so anyway, I'm going to flush this out, and then I'm going to sweat a process port on this line and pull a vacuum on both ends of the system. Okay, so we ran into some more problems with this unit. The cap tube is clogged, and I tried unclogging it, heating it up, and pulling a vacuum, and some other tricks up our sleeves, and it just didn't work. So we're going to have to change the evaporator and the heat exchanger, and so I laid the unit down on the floor so I can get underneath here. I took out this little clamp here. There was another clamp right here, and this is a T-fitting here because the one compressor supplies or works on both coils. So we're going to just free this up a little bit so we can get at it, and then we'll unsweat the suction line for the upper evaporator and run it up through the top, and then disconnect it inside, and we'll take that approach. Okay, so we're going to remove the evaporator. There's a couple screws on the right side. One's holding the sensor, thermistor. And there's another one up here. And sometimes, you know, we can clear the cap tubes out when they're clogged, but it doesn't work all the time. I hope you can see this because I'm not in a good position here and on the floor. Okay. All right, that's loose. I don't know if you can see, this is where we repaired the leak, but obviously it sucked in water and contaminated the system. So we're just going to cut that out and then pull it out and then put the new one in. Okay, do it the easy way. All right, we can pull the evaporator out and go out and get a new evaporator. Okay, here's the evaporator. It's a 421-1541. There's two in the box. They're both the same. And we only need one of them. Normally we change both of them, but since we knew this one had a leak, we'll just change the one for now. Okay, so we're going to fish this new line here through that opening. Be careful. If you've never done this before, be really careful bending this tubing. So we're going to straighten this out a little bit more to get it through that hole. Give us a little bit of an angle. Okay, and this goes. What I'm going to do here is it's hanging up in the back. Yeah. Okay. It's almost there. Pull it through. Okay, so I'm going to put one screw in here on this end of the evaporator. Give me a little bit of leverage. Put a light in here. All right, just get it started. This one's got to go up. Then we have to push this back. Got to make sure that stud there, that support, isn't blocked because that's what holds the cover on. This can be in the back behind it. All right, so it's almost on now. Let me get some light. Okay, so get this other screw here started. We'll be in good shape. Okay, you find that hole, you get that screw started. Okay, that's tight. I'll tighten up this one here. And then I'll put the thermistor back on. Okay, now like that. It's not in the way of the fan. All right, we're going to have to fill all this in here now because this putty is hardened, but we'll fill this all in with some silicone and make it airtight. But that's it, the evaporator is in, so now we just have to do the harder part, which is sweating the lines and bending the tubing. Okay, so now we're going to cut these cable ties here. This is the upper evaporator right here. I'm going to cut both of these. Give us a little room to maneuver in there. Okay, so we have to unsweat this, so we'll put something in here to block, to protect the that insulation there so it doesn't burn, and then we'll pull this out. Nope, look at that. Okay, so we're using a number 5 tip here because we're going to need a lot of heat to unsweat that. All right, she's loose. Okay, so it's out, and there is a little tag on here. It says upper, so we know we replaced the upper. And so now, I mean, we could play around with this and figure out where the restriction is, but it's not really worth it. It's going in the round file, garbage, along with the old evaporator. All right, so now we're going to clean up this joint, and we're going to snake this in and sweat it in. So stand by. Okay, we're going to clean up the joints. Now, probably one of the hardest things to do on this job is you have to make a 180-degree bend in this tubing to fit in this way, just like the old one. So I'd be really careful with that because you don't want to kink the tubing, and it's really hard to see with the insulation on there. So we're going to use a tubing bender and put a 180-degree bend in there. Okay, so I peeled back insulation so I get my tubing bender in there. I use this tubing bender here, and now I'm ready to sweat that back in. Get some protective. Okay, we want to make sure we don't burn anything here. So okay, and we'll sweat this in later. So we'll get our Stay Still 56 here, torch, sweat this in. And I'm going to heat the T-fitting to draw the solder in. I just don't want to loosen up the joints on the other side. That's it. Okay, we sweat it in. We put the clamp on. Now we have to sweat in the capillary tube here. I've already sanded it and put flux on it. And that goes in here. There's probably some solder in there. You want to get that in there so you can, so we'll take a little drill bit here and try to clean it out a little bit so we can get the tube in. Otherwise I'd have to heat it and to loosen up the solder. Yeah, I think I might have to do that. You want to get it in there at least an inch. Okay. Yeah, I'm going to have to heat it, but that's going to be kind of dangerous because if you heat it and the solder gets into the tip. All right, let me work on this. Okay, so now we're going to remove the switching valve, as you can see right here. And we have a new one over there on the bench. Probably should use a larger tip. There we go. Okay, here's the new switching valve. And so what we're going to do here, and these are all the pieces that come with it. Here's the instructions. Not very helpful, but just to reaffirm for which series unit you're putting this in. They're just telling you which is the lower valve and which is the upper valve. So this is for the lower evaporator, this is for the upper evaporator, and this is the filter. So this piece is going to get sweat. We'll sweat it into here like that, so that connects into the condenser. And then this piece will sweat into the other side of the dryer like this. And then on the end of this we're going to put a process port, because this is where it's going to come out by the compressor area, so that we can have a valve access to the high pressure side of the system. And the terminals on this valve, you can see they're different sizes, so you can't switch the wires. And so that's pretty easy. Okay, so we're going to clean this all up, sweat this in like this, and then we'll put it into the machine. Okay, so let's do some sweating here. I changed the tip, the number 5 in there. Okay, now we'll do the process port. Now the hottest point on the flame is the tip. So you don't need to touch the brass or the fitting, but you need to keep it as close as possible. Okay. Okay, so we're going to prep this up. Put some flux on the line. Also on the cap tubes, we've got some flux on there. So your condenser line will go to here. And this is the upper evaporator. This is the lower. It's actually marked. It says lower evaporator on there, not to be confused. And then if you look at the instructions, the lower evaporator is on the inside. So we're going to snake this in there like this. This is going to go in here like this. Okay, it's in there. This is the upper evaporator, the one we just replaced. Put it in about an inch. This is the lower one. Sorry about these video glasses here. Someday I'll maybe have a videographer on call. Okay, so that's in about an inch. So now we're going to use, see the aluminum here is going to protect the plastic drain pan. And so we're going to solder the discharge, the high side, and the 2 cap tubes. The process port's already on. And we'll screw this into the bracket and go from there. Okay, it looks good, so we'll mount that valve onto the bracket, hook in the wires, and then we'll pressure check everything, and then we'll start to put it back together. Okay, so now we're going to pressurize this system with nitrogen. Not very much nitrogen in there. So I need a refill here. Okay. We'll use some freon to pressurize it. Okay, so we ran out of nitrogen and we're pressurized the system with R134A. And we're just checking, make sure our sweat joints are good. And even check the factory joints just to be safe, because if you don't want this thing to break down when you bring it back to the customer's house. So that all looks good. And now we can put it back together, and we'll do pull another vacuum on it and finish up the job. Okay, so we buttoned this thing back up and checked for leaks. We pulled a deep vacuum on it. We refoamed, insulated this entranceway here for the heat evaporator using foam. And also you can see it on the inside over there. It's nice and tight. So now we've weighed 3.3 ounces in our charging column, and that's how much this machine takes. So now we're going to put the cover back on. Sorry for the glasses, but this is how I work. Okay, I'll get that on, and then we'll put the rear cover on, plug it in, and weigh the gas in, and we should be done. Be back. Okay, we are done with this machine. As you can see in there, 45 degrees in both sections, upper and lower. It's running quiet. We weighed the gas in, we let it run for a while. Everything's hooked up and ready to go. I just have to put the slides back in, but there you have it. That's how you do seal system repair on a 424. Changing the other evaporators is no different. And the switching valve, you've seen how that goes in and how to change it. So we're done. See you next time.